This video is about solving equations of the form solve 27 to the power of n minus 1 is equal to 9 by 3 to the power of n minus 2, or questions like this: solve 2 to the power of x plus 4 is equal to this, where there's no powers on this side at all. Or maybe solve something like this: 2 to the power of 12 divided by 16 is equal to 2 to the power of whatever. The thing you're going to notice about these is that all of these numbers have the same base. This 9 is 3 squared, and this is 3 to the power of 3. This is 2 to the power of something. I can turn this into 128 into 2 to the power of something as well. And the same with this one. I've got 2 to the power of something, 2 to the power of something, minus 2 to the power of something, divided by 16, which again is 2 to the power of something. Okay, here's the first one. 27 to the power of n minus 1 is equal to this. I'm going to change 27 to 3 to the power of 3. And that's all to the power of n minus 1. And that's going to give me 3 to the power of 2 by the power of 3n minus 2. Now, because it's powers of indices, I can now multiply the indices out. For example, if I have 2 to the power of 3 to the power of, say, 4, well, that's equal to 2 to the power of 3 by 2 to the power of 3 by 2 to the power of 3 by 2 to the power of 3, isn't it? Because that's what the power of 4 is. And each one of these 2 to the power of 3s is 2 by 2 by 2, each one of them. So 2 to the power of 3 to the power of 4 is equal to 2 to the power of 12. 3, 6, 9, 12. So if you multiply your powers, you get what the solution is. So in this case, go back to yellow, I'm going to get 3 to the power of 3n minus 3 is equal to 3 to the power of 6n minus 4. Because these bases are the same, I can now say that 3n minus 3 is equal to 6n minus 4. And now I'm going to bring my 3n over to here. So it's 6n minus 3n. And I'm going to bring my minus 4 over to the far side, becomes plus 1. That means n is equal to 1 over 3. So that's the solution to that one there. I would suggest when you get these solutions, put the numbers back in to make sure that you're happy with them, that they actually do satisfy the equation. It'll give you confidence. Let's move on to the next question. Now, solve this one. 2 to the power of x plus 4 is equal to 128. I want to convert this into a 2 to the power of if I can. And I happen to know that 128 is 2 to the power of 7. 2, 4, 2, 4, 8, 16, 32, 64, 128. So 2 to the power of 1, 2, 3, 4, 5, 6, 7. Okay, I normally do that in my fingers. So I'm going to get 2 to the power of x plus 4 is equal to 2 to the power of 7. So x plus 4 is equal to 7. So x is equal to 3. That's that solution. What would happen if it was something a bit different? What would happen if it was 2 to the power of x plus 4 is equal to 120? Well, now I can't go 2 to the power of 7 that quickly. Okay, so I'm kind of deviating a little bit from this lesson, but I would do log of 2 to the power of x plus 4 is equal to log of 120. And then I'm going to get x plus 4 by log of 2 is equal to log 120. And I'm going to get x plus 4, because that's all multiplied by the x plus 2, is equal to log 120 divided by log 2. And then they're going to solve that and subtract 4 from it. That would work as well. Check that out, make sure that works. Okay, that was just as an aside. Let's go back to the third question now. Now in this case here, let's convert the 16 to 2 to the power of 4 to start with. So I'm going to get 2 to the power of 12 over 16 is 2, 4, 8, 16. So it's 2 to the power of 4 is equal to 2 to the power of x plus 1 minus 2 to the power of x. I'm not sure what I'm going to do with this just yet, but I do know that I'm going to get, when I subtract these, I'm going to get 2 to the power of 8 is equal to 2 to the power of x plus 1 minus 2 to the power of x. Now, 2 to the power of 8 is equal to this here. I'm not quite sure how to handle this. Assume you're in a test and you're looking at this, you're not quite sure what is 2 to the power of x plus 1 minus 2 to the power of x. What I suggest is on the side, in a bit of rough work, okay, you start to think about what that might be. So let's give x some values. Let's say x equal to 5. So I'm going to go 2 to the power of 6 minus 2 to the power of 5. Well, what's that going to be equal to? Well, 2 to the power of 6 is 2, 4, 8, 16, 32, 64. That's minus 2 to the power of 5 is 32. That equals 32. Okay. Let's try maybe that's x equals to 5. Let's try x equals to 3 and just see what we get. We're just exploring with these numbers. That means I'm going to get 2 to the power of 4 here minus 2 to the power of 3. Well, 2, 4, 8, 16 minus 8 is equal to 8. 32, the same. Okay, let's pick a slightly bigger number. We say x is equal to, say, 7. Okay, that means I'm now looking at, imagine you're testing it. You've taken a minute to do this so far by putting in some numbers to see what it looks like, and you're getting a bit of an idea what might be the solution. So that's going to give you 2 to the power of 8 minus 2 to the power of 7. Well, 2 to the power of 8 is 2, 4, 8, 16, 32, 64, 128, 256, I think. 256 minus 128, and the answer is equal to 128. So therefore, this 2 to the power of x minus 1 minus 2 to the power of x seems to be just 2 to the power of x. This here is this one. This one is this one. And this one is this one. So therefore, my proposal is, without a very strong proof, I'm going to go 2 to the power of 8 is equal to 2 to the power of x. So x is equal to 8. So we've got a solution, x is equal to 8. It'd be nice to verify it now and just make sure that that actually does work out. So to verify, we're going to get 2 to the power of 12 over 2 to the power of 4. And we're going to check, is that equal to, check, suppose we're verifying, is equal to 2 to the power of 8 plus 1 is equal to 2 to the power of 9 minus 2 to the power of 8. And if you plug it into your calculator, you're going to get 2 to the power of 8 is equal to 2 to the power of 8. So it actually does verify. So that's the solution. Okay, I hope that helped.